All right, here we are in what we're calling the lab in Lynn Dorm at Harding College, and here with Eric, and he's going to tell us a little bit about his project.
Yeah, so here are all the parts for the project. I'm just going to talk about each one. Right here is a 4-inch inline fan. There are going to be two of these in the garden. One is going to be at the top to outlet air, and one is going to be at the bottom to inlet air. Connected, we have two air back dampers. The purpose of these is, since you're trying to have a controlled environment, you of course don't want air leaking out from where it came. So basically, air can come one way, but it doesn't go the other. Right here we have this is a dehumidifier. This is just for maintaining your correct environment levels, in this case humidity. Here, this is an Arduino. This is actually not the one we're going to be using in the garden. That is over here. This is an Arduino Mega 80K version. This is special because it has USB connectivity, so using Google's Open Accessory Development Kit, you can connect to any Android device such as a smartphone or tablet. So yeah, this Arduino will be sending relevant data to the tablet on the front of the garden, so you can interact with it in a nice user-friendly way. Right here, these are 4 electric solenoid valves, all on one board. The purpose of these, two of these will be used to control acid and base, and 2 of them will be used to control nutrient concentration. So, for example, you will have a pH sensor, and if it gets too acidic, you're going to send a high voltage, and it will open the valve, and you can put more base in to neutralize it, and it works vice versa. And then for the other ones, you're going to have an EC meter, which measures nutrient concentration, so you can apply nutrients accordingly. This is a reverse osmosis filter. This is because if you want these gardens to work in any environment, depending on where you are, the tap water is harder or softer. This means certain water will have different pH or different nutrient levels. So this kind of just gives you a consistent input. Here, this is the liquid level controller for the reverse osmosis system. Basically, this is a fairly accurate air pressure sensor, so if the reservoir water level drops by 1 inch from either evaporation or plants actually using the water, then this will open another electric solenoid valve and allow purified water to flow back into the reservoir. This is an 100-watt water heater. This will sit in the bottom of the reservoir, and when the water temperature gets too low, which is there's a certain operating range for the plants, a certain water temperature that they grow best in, and so if it gets too low, you turn this on until it reaches your desired level. This is a pH probe. Basically, this will sit in the reservoir and will continuously measure pH. And say if levels get too low, then, as I said earlier, you'll put in more acid or base depending on what you want. This is a EC meter. This water comes in this way, comes out that way, and this measures nutrient concentration. So this is a digital way to measure if you need to put more nutrients in of a certain kind or not. And yeah, this will hook up to the Arduino. This is the garden's power supply. This is a 500-watt, 24-volt DC power supply. Basically, this along with voltage converters will power the entire garden. This is a 5-pound CO2 tank. For your environment, you want to control CO2 levels because it's important since it accurately monitored CO2 levels can increase plant growth by up to 300%. So this will basically store enough CO2 for hopefully months. This connects right to the CO2 tank. This is a flow gauge. You can switch it from outletting 0.5 cubic feet per minute all the way up to 15. This is just a pressure sensor to see how much CO2 is in the tank. And then right here is another electric solenoid valve. So if your CO2 levels drop, then you can open this valve and allow CO2 to be administered in the environment and get the desired levels. You look over here. Here we have a NDIR CO2 sensor. Basically, this continuously monitors CO2 levels in parts per million in your environment. And using this, you can accurately control the amount of CO2 in your plant environment. Here, this is just a system diagram. I just made this just to make sure I have each system kind of mapped out and what kind of power it needs. It's just like a visual aid. Here, this is kind of small, but this is actually the wiring diagram for every sensor and actuator in the garden. And this is a wiring diagram of the LEDs. I don't have those yet, those are still being shipped.
So what else do you still need?
So what I need is, this is a 1/10 horsepower water chiller. The issue with this is that it's, as you can see, it's pretty big and it will not fit in the garden. So I'm going to send that back and buy a 120 horsepower water chiller, which has about half the footprint. Another thing I need to send back is this carbon filter. Ideally, this would be a 4-inch carbon filter that would fit right onto the fans I showed earlier. But these are basically only manufactured for industrial uses, and no one really makes carbon filters that are on that scale. So I bought two. I'm thinking about sending back one and then modifying one to fit. And the purpose of those are that on the inlet, you don't want dust, you don't want anything to contaminate your environment. On the outlet, you don't want the plant matter smell to stink up your room.
All right, it seems like that's it. Thanks for watching. Eric's clearly hard at work, and hopefully this will be start of something big.